Oh boy, now I get this whole thing. Maybe if I just do this, there it goes. All right, leave my little face here. Hey, math team today. So you know, get a little contest. I think it's the first contest of the year for math team. I think it's here. So yeah, homie. Okay, Frozen. Sorry, but online they see a move here. All right, don't write any of this down. But this is the why. We got to do some square roots today and talk about perfect squares and blah 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 blah. This was done by Mrs. Fasola, who she loves the I can statements, whatever they mean. I can simplify square root by extracting square roots. That's what we're doing today. I can simplify square root by extracting non-real roots. What? There's something called a not real number. That sounds goofy. All right, so why are we doing this? First of all, look at this picture right here. You see this parabola? What does this parabola not cross, everyone? Starts with, well, it's a letter. 3, 2, 1, go. X-axis. All right, so we had intercept form for a parabola. Well, what if the parabola doesn't cover your nose? Okay, what if the parabola doesn't cross the x-axis? Well, something weird occurs with these solutions. There's still going to be solutions for something like that. And then if you read this, there are no real solutions for this parabola that doesn't cross the x-axis. They're actually called imaginary. That sounds made up, but it's not. There is a subset of numbers called imaginary numbers, and you're going to be introduced to that today. It's a very, very simple concept. Also, though, you could have a parabola that does cross the x-axis, but the solutions are not nice whole numbers or fractions that are nice. That represents a factorable situation. So what you'll end up with is irrational or radical solutions for said parabolas. So that's why we have a little disconnect. If you've never simplified a radical, then you cannot solve quadratics that have these cases occur. So we need this day today. We need this day of simplifying radicals. Okay, so this is what I did real quick before you guys walked in. Not only those perfect squares that I have listed up here, but I firmly believe some of you need to print one of these blank ones and fill these in. I feel like there's a lot of people that don't know their times table. Maybe it's the deer and headlights when I call you as a number, and they're like, oh gosh, my honors, or no, my CAT students, I think I'm finally getting them, but like, what's 3 minus 6? What's 3 minus 6? 3, 2, 1, go. -3. I get like 9. I get -9. I get all these weird answers. I know that's not a times table, but it's just knowing what a negative is and how to deal with those. So I really think this is something that some of us should actually invest in. We used to have we don't have a planner this year, right? No one passed out a Porter planner. There used to be times tables in the Porter planner. There used to be a little math section, and they had this. All right, but also you probably should start with writing these down. These, I believe, are perfect squares that you ought to know. All right, and if you don't have to write it down because you know them, then don't. I did throw this last one here, 225. That's 15 squared. I really think people should know the 15 squared thing too. I skipped 14 and 13, but the times tables in grade school usually go up to 12 squared, right? So that's why I have 144 there. A very valuable thing for what we're going to be doing next. Give you a moment to write these down. I don't feel bad about not knowing your times tables. It's an epidemic. I don't know what happened with some of the basic skills out there. Oh no, one of my pandas lost its face. Okay, put that back on. Oh, and then I got to go do some more shopping. Because there's gonna be a lot of big winners tomorrow. There we go. That panda's fixed. How many people have won an eraser? Raise your hand. Come on. Nice. You? Yes? Huh? Yes? Anyone do the game? I love the game one. This is like my new favorite. Like a game. Okay, ready? Okay, let's zoom in on this one. Okay, everybody. We'll leave you alone, but we'll do group responses. What's the square root of 36? 3, 2, 1, go. 6. This is the point. And everyone can answer that, and no one has a problem. Please don't put a radical over that. Some people do goofy stuff. I don't know how to explain this. Square root is asking what times itself equals 36. That's what this means in words. I'm not writing that down. So that's why it's 6. Do I have a perfect square with 63 as it stands? Yes or no? No. But this is what you got to do. You got to know your times tables. What is 63? What times what? 3, 2, 1, go? Okay, I've heard a couple people say 9 times 7. And that's what I mean about our times tables. And I would like that other than, what, 3 times 21? Right? Okay, then I can ask everyone, and this is how this really works. You can really separate this into 2 separate square roots. And I could ask everyone, what's the square root of 9? And they would answer what? 3. Everyone can do that. But then why do I get goofballs that write this as like 7 root 3? I get like the craziest answers for this. What's the square root of 9? 3. So 3 is free. 7 is not, because 7 is not a perfect square, so it's stuck in jail. I just get the goofiest answers with these square roots. I think it's people that, when they look at a notes that teachers give them, they try to be a robot and memorize the tricks and not really think mathematically. I don't know what it is. What I'm trying to explain it to myself over the years why I get certain answers that I do. So, and then in talking out loud with that, hopefully I'm resetting your brain so that you don't become that person. I don't know what 108 is off to the top of my head, so I'm going to do 2 times. Because I know 2 goes into 1. Stop! What's 1 plus 0 plus 8? What does that equal? 9. Do you know there's a special divisibility rule? Then what goes into 108? 2 numbers. Which one? No. 3. But then 1 plus 8 plus 0 is 9. So what else goes into it? 9. That's a special divisibility rule for numbers. When you add the digits, if the sum of the digits is divisible by 3 or 9, then that number itself is divisible by 3 or 9. And it's only those 2 numbers, no others. Okay, so now I know it's 9 times something. Uh-oh, I put myself in a position here. So 9 times what? 9 times 10, 11, 12? 12? Okay, and then what's 12? What times what? Don't say 2 times 6. Something better. Why is 4 times 3 better? What's 4? And then here's how I do this. You know what I do? I come back. I write this like this. Oh, wait a minute. What's 9 times 4, everybody? And then 36 times 3 is what 108 is. And then I could ask, what's the square root of 36, which we already asked. 3, 2, 1, go. And I don't know why I get goofiness of people not being able to pull that out and leave the 3 on the inside because it's stuck in that radical. You've never done this before, right? Yes, no? Really should be a math 1 thing. I don't know if it used to be, and then COVID, we lost some chapters because we had to really shorten what we taught. Really should be in Algebra 1 or Math 1. But that's okay. We're actually going to have a whole unit on simplifying radicals much more in depth, but we're just doing the minimum what we need to do in order to do tomorrow's stuff and Friday. Right? And I think you'll be okay. There is just one formula Friday you're going to have to memorize. I really do. By the way, what has to go in 405? What number? 5. And I feel like this is a problem too, just talking about numeracy, just knowing a number that ends in 5 has to go into it. You know, these divisibility rules. Got myself. Oh, wait a minute. Isn't that 81? Isn't it 5 times 81? Right? 5 times 80 is 400, because 5 times 8 is 40. And then 405. One more 5. Done. 2 times square root of, I probably want to write 81 first, then 5. Then everybody, what's the square root of 81? And now I'm going to slow this down for note purposes. Yes, we did this in CAT. We have a chapter P where we do a whole bunch of different review concepts all in one chapter. It blows their mind. They get all blown away with their chapter P test. Wait, I was supposed to know this stuff? Yes, you were. But one thing that they missed was that 2 is out there. They ignore it, right? Don't ignore that 2 is on the outside. Now that the 9 comes outside, then they have to be multiplied. right? So just wanted to make that point real quick. All right, now really basic stuff. Like I say, we have a big square root unit coming up when we have square roots of variables, and yeah, that's later. We're just doing this basic stuff now. But here's where we got a problem: the imaginary unit, an imaginary number. Now, to be honest, there is no I don't get it's on this. There is just memorization, right? And there is just this is the thing. And I'm being truthful on this. I wish I knew who the person was, but back in the day, ancient times, I don't know how old this unit is. Somebody said, we got a problem. And it's that. What's wrong with this? Why can't this be evaluated? Yes?
You can't have a negative times negative.
Right. What is a negative times a negative, everyone? So there is not a number times itself that could possibly equal a -4. And that's exactly what she's saying, because she said the negative times the negative rule. This is impossible. This doesn't work. This is impossible. So here's what somebody said. They said, wait, hold on a second. We got to be able to do something with this. Let's do this. Let's separate this and isolate that square root of negative, and let's call it square root of -1. And now I can write that as the square root of 4 separated from that negative unit there. By the way, what's the square root of 4, everyone? 2. And then somebody said, I'm being honest, somebody said, you know what, let's call this something so I don't have to look at it anymore. And then they said, well, let's call them imaginary numbers. So we'll call the square root of -1 I. And I'm being truthful. This is the truth. From here on out, I is no longer a classic variable. A variable means it could equal anything. No, I equals the square root of -1. So now what this person said was, okay, now we can write this. Square root of 4 is 2. Square root of -1 is I. Therefore, it is 2I. And everyone else is like, wow, that's a great idea. Let's do that. Be truthful. As a fat or Mac, look at your graphing calculator. You got to do this, though. Mode. And then look down. I got a big screen here. It's like a whole bunch of stuff. Notice my calculator is in real mode. Interesting. Look at the second mode, A plus BI. I'm going to go on that mode. And then second quit. And then watch. Square root of -4. By the way, I think somebody in here has a Casio calculator. You're gone. You're not allowed to use that Casio anymore. There's a reason the Casio does something that is not good for a teacher. It makes you be a calculator copy and screen bum. All right, so just be aware of that. If you have a Casio, you will not be able to use that, and you shouldn't use it. And just I'll leave it at that. Mode. Let me go to real and show you what it does when I have it in real mode. Second quit. I should have the time for this. What time do we get out of here? What's the screen say? What is it? 11:08. I think this says not a real answer now because I'm in real mode and it's not real, right? So notice how that happened when I got out of A plus BI mode. But I did want to show you that that's a thing, all right? And that's what's going on there. Oh, and I forgot to show it on the calculator. What I'm going to show you next. You know what I squared is then? And this is where we're going to stop with I numbers. When we continue on, I think we do have an imaginary unit thing where we keep going with the I number. Some crazy stuff does happen when we raise it to further powers. But it really is simple. And maybe you don't know this, but what do you think the square root of 2 times the square root of 2 is? First of all, what's 2 times 2? So this is the square root of 4. What is the square root of 4, everybody? 2. So what do you think the square root of 7 times the square root of 7 is? Real fast, what's the answer? A free 7, right? You know what I squared is? Square root of -1 times the square root of -1. No, you can't take a negative times a negative in this case. But what you can see is what I did over here. Oh, square root of 2 times the square root of 2, free 2. Square root of 7 times the square root of 7, free 7. Square root of negative 1 times square root of negative 1, free negative 1. And you better understand that there's a huge difference between negative 1 and the square root of negative 1. Just like there's a huge difference between 144 or the square root of 144. What would you rather have, $144 or the square root of $144? Which one would you rather have? 144. All right, so understand that there's a major difference. Imaginary, real. All right, so when you square an I number, you actually turn into a real number. By the way, I numbers are very strange. You're like, why do I have to learn these? We would not have light in this room if we didn't have I numbers. All right, electricity, electrical engineers deal with I numbers. Just something that I've read in the past, and there's many other applications to it. So just so you know, everyone can answer what the square root of 25 is. What's the answer? 5. But this is what you really have to do on these kind of things. You have to isolate that square root of negative 1, and then you're dealing with the square root of 25 as a real number part. Okay, everybody, look at me. What's the square root of negative 1? 3, 2, 1? I. It just is. There's no I don't get it. Someone that says I don't get it, I go, what do you want me to do? This is somebody made this up. You have to memorize this. There's nothing else I can't approach this a different way. It is what it is. So actually this becomes 5 and then I. This is how you want to write it. You don't want to write an I5. You do want to write it like you'd write a variable. But remember what the word variable means. X is something different every single day. Right? That's why it's a variable. It's changing. I is the square root of negative 1. It is not a variable. Oh no, what's 26? Isn't that 2 times 13? Any perfect squares in there? Any perfect squares hiding? No, so that's stuck in jail, just like you might feel in my classroom. So, everyone, what's the square root of negative 1? 3, 2, 1? I. So actually, this is just I root 26. Okay, fine. Or root 26 I. I just don't like writing it that way. I think the book writes it like that. If you write it like that, make sure you stop that square root. And then the I is after that square root. But one way or the other, I'm always going to write it I root 26. I don't care what the other teacher's doing. It's a semantic. It's a minor detail. Not a big deal. Some people get all, like some of these math teachers here, very big sticklers. All right, 27. I should go around the room, but then this is just times tables. I mean, I don't know what else to tell you. I'm going to stop right there. Because everybody, what's the square root of 9? 3, 2, 1, go. So I know I have a perfect square. So in your mind, you don't have to do this every single time, but I am. So that you understand how we break this down. What's the square root of negative 1, everyone? 3, 2, 1, go. I. What's the square root of 9, everyone? 3, 2, 1, go. So 3 free, I, because of the square root of a negative, and then root 3 stuck in jail. That's how I'm going to write it. Any questions so far? I know I get scary about it. You should know. There's no, I mean, I don't know what else I can tell you. You know, there is no I don't get it on this. It's a brand new thing. You lock it in and move on. All right. Square root of negative 162. Okay, we have a 2 out there. Sorry. Hey, here we go. What's 1 plus 6 plus 2? 9. So what goes into 162? 3 and 9, but I'm going to go with the 9 because 9 is already a perfect square. So this is how you break out stuff in a radical. You try to find the perfect squares. All right, now I got to, oh boy, 9 times what? Does anyone figure that out? 9 times 20 is 180. 20, 19, 18, 9 times 8, 7, 9 times 8? No, 9 times, I'm sorry, 18. Is that right or no? Yeah. Is that right? Okay, you know what 18 is? 9 times 2. What's 9 times 9, everybody? So I'm going to write that as 81. But that's also a thing, too, where a square root of 9 times 9, it's a free 9, right? And 9 does come out. But I'm going to go ahead and break this down like this. 2 times square root of negative 1, 81, and then that 2 left over. So I should have divided by 2, darn it. I would have divided by 2, I would add 81 right away, and then it would have been faster. So sometimes it's faster to do one way or other. Real quick, go ahead. Oh, I am right now. Okay, I'm not done yet. Okay, so what I did is identified what the perfect square is. Now we're going to go through the process. Hey, everybody, what's the square root of negative 1? 3, 2, 1, go. Hey, everyone, what's the square root of 81? 3, 2, 1, go. 9. And then root 2 is stuck in jail. So here's how I'm going to write this. Let's write the 9 next to the 2. And then the square root of negative 1, we put I there. Cross those off and cross those out because they came out. They got evaluated. All right, and then square root of 2 is stuck in jail. Again, I told you about my CAT students. They ignore that 2 is out there. I don't know why. Right? Now the 2 gets multiplied by the 9, and it becomes 18 I root 2. Okay, so the introduction of what an I number is. Just 18 times the square root of negative 1. I think, done over here. Okay, 4 more, and they don't take too long, so it's not a big deal. Ooh, okay, so I got a negative 4 on the outside, and I got a negative on the inside. Those negatives don't mesh. How did I get 216? I think I did it 2 times, maybe, the other hour. Because 6 plus 1 is 7. Oh, gosh. 6, 7, 8, 9 goes into this. I'm doing it again. I don't care. Holy cow. How many times I have 9 going into something? 9 times 20 is 180. What time do we get out of here? Oh, wait. It looks like people are packing up or something. All right. 24. Nice. 9 times 24. So if you do have a calculator, fine. You know 9 goes into it. Just divide by 9 to see what's left over. 24 is various things, but what should I make 24? What times what? 6 times 4. Why? 4 is a what? Perfect square. Now watch what I do with this. And 6 is 2 times 3, so 6 is nothing. I'm going to do this. What's 9 times 4, everybody? 36. So this is how I'm going to write it. Square root of, I got a negative 1 to isolate, and then this is 36, and then this is 6. So I can ask, what's the square root of 36? What would your answer be? 3, 2, 1. 6. We know that. All right, so this is negative 4 times this 6. I like doing that to get, so I know it came out, it got evaluated. And then square root of negative 1 is I. These do not mesh, the I and the negative. Okay, so you have to understand there's a complete difference there. And then we have root 6 left over from the leftover part. So this becomes negative 24I root 6. All right? Like I said, we are going to have a whole radical unit where this is going to come back. And then we go way further. You don't have to worry about that now. Oh, no. Now look at that. We got an I out. Now you're going to start seeing something special happen here. Finally, what's 2 plus 8? 10. Finally, I have something that's not divisible by 9. But 2 times 104. 104 is 2 times, is that 52? And then 52 is 2 times, this is an ugly one. And then 26 is 2 times 13. I never needed a calculator. Hey, by the way, what's 2 times 2 times 2 times 2? 16. So that's what I'm going to write. 2i square root of negative 1. Let's write that and isolate it. Times 16 times 13. That's how you do this. You have to tree it out, fine. But don't write the whole tree down. Go back and identify the perfect square. Because everyone, what's the square root of 16? 3, 2, 1, go. Everyone can do it. It's so simple. Oh no. I have 2i out, and then I have to pull another I out. Interesting. And then square root of 16 is 4. I choose to write that out there because it's going to meld with that 2. And then the 13 is stuck in jail. I don't understand why people make radicals tough. You really get it to understanding perfect squares, then it's good. Oh no. What did I tell you I squared was, everybody? I squared is negative 1. Not square root of negative 1, negative 1. So this is negative 8 root 13 is actually what happens. I have to show you on the calculator. Hey, you don't trust me, huh? All right. Here's the I button. It's right down here. Second, I didn't do it with you guys. Squared. Watch. Ready, set, go. Boom shakalaka. I'm back in fake mode. Actually real mode, not imaginary mode, and it still does evaluate I squared and shows that it's a free negative one. So you trust the calculator does the same. All right. So I squared is a free negative one. Okay, and then these last two, it's because you're gonna. How many people have heard of the quadratic formula? Anyone have ever heard of that before? Raise your hand. Good. That last one mirrors the quadratic formula, and then that's why we need to know how to simplify a radical. If we don't know how to simplify a radical, how are we going to do the quadratic formula? But actually, what we have to do tomorrow, we need this too. PEMDAS, by the way, what do you do first? Do you subtract or do you square? Square. Do you multiply or subtract first? Which one? Multiply. So that's the point of this one. You do 6 squared. Ooh, and I like this. Minus, and then 4 times negative 2 is negative 8. Negative 8 times 3 is negative 24. Next thing, do you think you take the square root of 36? Yes or no? The answer is absolutely not. The only time you can take individual square roots of numbers is if they're a product all the way across. So I cannot take the square root of 36. That's the value of this one. I'm trying to think how that's a PEMDAS error. I think you have to, it's like parentheses. This is like parentheses. You have to get everything done in the parentheses before you go outside of the parentheses. It's called for PEMDAS, P stands for, everything that's inside a certain operation as well. So you can count that as the P thing. This parenthesis has to be done first. Wrong. Isn't it 60? Right? Minus a negative is plus. Now I know 60 is 6 times 10. 6 has a 2, 10 has a 2. So I know 60 is 4 times something. And what is that something, everybody? 15. So I did think about 6 times 10. Neither one are a perfect square, but both of them have a 2. So I knew 4 goes into this. What's the square root of 4, everyone? Don't be robots. Where's the I? I thought you told us about I's. Is there any negative on the inside? Yes or no? Don't be robots. All right? It bounces back and forth between I and maybe not I. Last but not least, PEMDAS for sure. This is what the quadratic formula on Friday is going to look like when you start inserting numbers. Friday, you're going to have a formula memorized. This makes me infinitely sad. Look at this on the inside, negative 3 squared. Oh, you button pushing bums. Those people, why? They don't know their times tables. Because they always hit the calculator. Watch what negative 3 squared typed like this gives you. And how many, I am going to call you a bum. How many people write that on their paper? Ah, what is a negative times a negative, everyone? Positive. I will get people on Friday for the quadratic formula write a negative 9 in that position. It drives me insane. Okay? So don't drive your teacher insane. 3 minus a root, and then this is a 9, not a negative 9 after everything I just covered right there. You probably had your hand up there. Shouldn't I use parentheses around the negative 3? Yes, that's the point. What's your hand up for besides that, maybe? Because it doesn't, because actually, like when you remember when we had negative x squared plus like 2x and you had to evaluate x equals negative 1, right? That negative is on the outside, just like it was on the outside there, and it does not get squared. So this calculator is doing the right thing. You are telling the calculator that the negative is not squared. All right, just like the negative is not squared in that negative x squared question. You understand what I'm saying? Okay, so that's why the calculator evaluates that actually correctly. All right, so remember with this, you had to do this first. You had to square the negative. Now that is squared, but then it turns into negative 1 after, right? Because it's not part of that. All right, so moving on. 4 times 5 is 20. 20 times 2 is 40. And unfortunately, nothing special happens with this. except for what's 9 minus 40? Negative 31. I'm not going to allow you to write that. What do you have to write this as? What kind of number? What kind of number is square root of a negative? An I number. So you have to write this as I times the square root of positive 31 over 10. And unfortunately, 31 is prime. So I don't get to bust out anything else after that. Okay, so that's done, but let me show you one more thing, because I wish I had a better example than this. Let's pretend that we had an example next to our times tables here, and we ended up with this as a almost final answer. Let's say it was 2 plus 4i root 3 over 8. Here's another naughty thing in math that I see students do all the time. I see students that say, oh, okay, those cancel 2 over 8. That becomes 1 over 4. Wrong! I call this a 6 over 5 equals 2 error. Get ready for this. First of all, is that true? Does 6 over 5 equal 2? Yes or no? No, it doesn't. But watch this silly math. Hey, isn't 6 5 plus 1? Just answer my question. Isn't 6 5 plus 1? Right? Okay. So I'm going to write 6 as a binomial. 5 plus 1. Oh, and then I'm going to cancel these 5s. And 1 plus 1 is 2 over 1, which is 2. True or false? True or false? True or false? False. That's not true. That's because this is an illegal thing to do. You can't take part of a sum and cancel it with something else like this. It's illegal mathematically. It turns into answers that are wrong. So therefore, if I can't do that with 6 over 5, I can't do that with this. I get this all the time. My CAT students do this terribly. You know what you can do though? You can factor. What does that 2 become if I take a 2 out? What does that 2 become? 1. What does that 4 become? 3, 2, 1, go. 2. 1 plus 2i root 3 over 8. Now that 2 is free as a product to be canceled with this 8. And now that's how you simplify that. Or so you can split this up into 2 separate fractions and see how that cancels like that. Another possible answer would be 2 over 8, which is 1 over 4, plus, hey, what's 4 over 8? What's 4 over 8? 1 half, so it would be 1i root 3 over 2. This is another valid answer for this question. You're able to do either or, all right? But you're not able to just cancel the 2 and the 8, because that's wrong. So I didn't show this to the other period, that was an option as well, splitting it up into 2 separate fractions and simplifying. Definitely a truth there. Hey, look at your worksheet. It's a half sheet. So it ain't going to be that much. And then that other assignment is due, that worksheet. And it's on you if you didn't do your computer thing. So that's due by the end of tonight.